Hi, on the workbench today is a Ryzen RK6006 360 watts buck converter module. It can output from 0 to 60 volts and has a maximum current of up to 6 amps. On this channel, I had reviewed the Ryzen RD series DC to DC converter before, so when I was offered to review this unit by Banggood, I initially thought there might not be that much of a difference between this model and RD series. But upon closer look, I was wrong. The first thing you'll immediately notice is the size difference. For comparison, here is the RD6012 that I had assembled into a power supply a while back using a few spare power bricks that I had lying around. And you can just see how much smaller the RK module is compared to the RD6012. There are a few noticeable differences between the RK and RD series besides the drastic differences in size. The most obvious one is that the RK series do not come with binding posts. As you can see that both the inputs and outputs are on the rear terminal here, whereas for the RD6012, they're on the front panel, and these are actually soldered onto the module itself. Now, this does cause some inconvenience if you want to make it into a standalone power supply, as you will have to supply the binding posts yourself. But the plus side is that you have more freedom in terms of the placement of the binding posts. Without the binding posts may not be a problem for everyone though, especially if you wanted to use it as a variable power supply for some fixed applications. So it all depends on the use cases scenarios. Given the size and affordability of this unit, I can definitely see it as a great replacement for your typical DC to DC converters, like the one I have here. If you see this one compared to the RK6006, you'll see that they are similar in size. This one I would argue is a little bit bulkier just because of the dimensions here. But you can see that this one has two giant heat sinks, whereas the RK6006 has this just smaller heat sink, so it's probably even more efficient. Nevertheless, these two are comparable in size. But this one is definitely more feature-rich, as you don't need a separate voltage and current measurements, as they are already built in. Now, one potential issue is that because there is no 4-wire sensing on this RK6006 module, the voltage at the output end will likely be quite a bit off if there is any significant current due to the voltage drop along the terminal wires. The RD series do not have 4-wire sensing either. But these binding posts, as you can see here, they are mounted right on the circuit board, so the resistance of the connection is minimum. The RK series also did away with the numeric pads found in the RD series. This means that entering data could be a little bit more cumbersome, as data entry now has to be done via the rotary encoder. We'll see that a little bit later. It also has a connector for an external fan. Let me just flip it over and zoom in a little bit so you can see it. So you can see here, this is the fan connector. The external fan would kick in if the output current is above 4 amps or the module temperature is above 45 degrees Celsius. The module also comes with a spare fuse. And if you look at the circuit board, you will see that we actually have two footprints for the fuses here. One is factory soldered on, which is to the right, and the one supplied can be pushed into the holder that is currently empty, should the default one blow. The RK6006 also comes with an external thermistor, and you can plug it into the connector back here that has a thermometer symbol next to it. To be very honest, I'm not sure why you would need an external temperature sensor with this tiny power supply. The original RD series has one, and that is because it has a dedicated charging output post. The idea is that you can use an external sensor to monitor the battery temperature you are charging. Now, I suppose you could use this module to charge a battery as well, but there's no automatic cutoff if the external sensor detects an over temperature situation. Alright. Now I have hooked up the module to the power supply. You can see that the input terminals are hooked to a bench power supply that can output 60 volts, 6 amps. That is a linear power supply, so later on we can use that to test the output ripple of this switching module as well. Now, in order to test the maximum output from the switching module, I do need a power supply that can output maybe 68 volts, but I don't have one. So unfortunately, we will have to live with that one. This means that when we're testing the maximum power dissipation, we can only test up to 300 watts instead of 350 watts that is specified for this module, which is going to be close enough. All right, let me turn on the bench power supply. I would say it probably took about 3 seconds for the RK6006 to power up. Now everything looks pretty sharp here on the screen. The multimeter here is a little bit distracting, but I do want to see the output voltage accuracy, at least at the very beginning. And let's turn on the output. Wow, the output is 5 volts bang on. So that's pretty good. Now let's adjust the output a little bit and see what we got here. So to do that, you press VSET, and you can see that we immediately have a cursor here. So let me just zoom in a little bit more. Unfortunately, right now, this is where a keypad would be very helpful, but we don't have one. So you have to press the button here to shift to different digits. So let's say we want to change it to 10 volts. And so now we're at 10 volts. Of course, the output is off. Let me turn the output back on. The reason I can't turn it back on is because now I have the over voltage protection set. So let me adjust that. Actually, this is quite good. That prevents you from accidentally set a voltage higher than the desired voltage. So let's actually first change that over voltage. Now to set over voltage, you can't just press VSET. You can see here, VSET changes the actual output voltage. Now to update the over voltage setting section, you have to long press the VSET. You can see that. Now we can change the bottom number here. So let's change it to 10.5 volts. And that should be good. So now let's turn on the output. And you can see that the output is at 10 volts. So now let's just crank it all the way up to 50 volts and see what we got here. So again, I have to set over voltage to, let's see, 50 volts, 50.5. And now I'm going to set the voltage to 50 volts. So you can see now the output is at 50 volts, pretty much bang on. So at least from the casual testing, you can see the voltage setting accuracy is very good for this RK6006. Now I just zoomed in a little bit more so you can see it better here. Besides being able to set the voltage, of course, you can also set current. So you do that similarly with the iSet button. Here you can set the current output limit. Right now we're setting at 1.5 amps. You can set it all the way up to 6.1 amp. And similarly, if you long press this button, you will be able to set the overcurrent protection numbers here. So the overcurrent currently is set at 6.2 amps. The different settings are similar to those found in the RD series, but I'm just going to point out a few here. For example, if you want to save the current settings as a preset, all you do is long press the OK button, and it will ask you whether or not you want to save it. So you can use this knob to select different locations. Let's select number 8. You can press the button here to acknowledge or cancel it out. Let's do OK. So let's save it to slot number 8. And let's just double check that. So let's, for example, now I'm changing it to 49.51 volts. And let's recall that. So to recall it, you press and hold this button. Sometimes it takes some getting used to, as depends on where the cursor is at. It may or may not be able to activate. I think we need to get out of that setting first. So let's press and hold. Yep, we can recall this. So you can see I have already stored some values here, but let's go to number 8. And that's our previous setting that we saved. So now, again, we can use this to either acknowledge or cancel. So we want to load the setting, so I press OK, and you can see that the settings from that specific memory slot is restored. And those, in my opinion, are some of the most commonly used functionalities, and you can get used to very quickly. But there are quite a few extras that you can also set, and those are not as obvious as what we have seen. Now to get to the menu, all you do is short press the OK button, And you can see we have these menu items. Some of these are very obvious, some of these are really obscure. You use the I set to go down and the V set to go up. So let's say language, you can change it to different languages. That's fairly straightforward. So what the heck is this takeout? Well, I'm very disappointed because in the RD series, they have essentially the same description. And these descriptions are just outright confusing. So what this takeout really means is while you are switching from different memory settings, the output would be on or off once you switch to that new range. For instance, currently if we're at 5 volts, if you store the setting for 6 volts, when you change to 6 volts, if the takeout is off, then the output stays off. If the takeout is on, then the output would be default on. That is actually quite dangerous, so I would recommend just keeping it as off, which is default anyway. So the same goes with boot power. Now this one is slightly more descriptive, but it's still very, very confusing. What that really means is once you power on the unit, whether the output is on or off. So by default it's off, which is the preferred setting. But of course, if you do want it to turn on, you can actually just switch it to turn it on. But I would not recommend it, as you could accidentally outputting a wrong voltage when hooking up your circuit under test. So let me actually demonstrate that, the takeout and boot power for you right here. So let me go back to takeout. So let's say we change it to on. Now we wanted to save the settings here. Let's do that. Let's press OK. And we save. So now let's recall one of the settings here. And notice the output here. So right now, let's just recall the first stored setting at 5 volts. We say OK, and you can see that the output is immediately on, which is not desirable in my opinion. So let's go back and switch it off. Once it's off, let's save it again, and let's try it again. So again, I'm going to recall. And this time I'm going to recall the second voltage setting, which is 9 volts. Let's say OK. And you can see that the output is turned off. So now let's take a look at the other one, which is the boot power here. So again, the boot power by default is off. And if we turn it on, so let's see what happens. Let's save it first. And let's power it off. So remember, when we initially power it on, the output is off. So now let me turn off the power supply here. And now I'm powering it back on. You can see that this output is immediately on as soon as the power supply powers up, which again is not desirable. So let me change it back to default off. Anyway, let's move on here. So you can display the boot logo, whether or not you turn on the buzzer, backlight, update rate. And the update rate, right now I turned it to high. By default is slow. So actually, I think keeping it high does give you some benefit as the voltage measurement updates at a relatively fast rate on the front panel here. So let me leave it as high. And maximum power is 380 watts. Temperature degree is Celsius. Now, this is a new feature on this RK6006. And what it does is if you set, for example, this to 90 degree, and let's try that. Unfortunately, it doesn't take effect immediately, so I have to power off the unit here. And once you power it back up, what you're going to see is actually the display is rotated based on the setting. And that is actually useful if you wanted to mount, for example, this unit vertically instead of horizontally. And that's actually very neat, as you can also mount the other way around just by changing it to 180 degrees. So let me change it back to 0 here. By the way, you can see 180, 270, and of course we will change it back to 0. I would have liked if this change takes effect immediately, but it doesn't. So you just have to, unfortunately, power it off, and that's when the change takes effect, when you reboot. So let me reboot. And now let's go back to the manual. Now the model I have here is the RK6006-BT. I forgot to mention earlier, it does come with this Bluetooth module plugged in on the side. So this is a removable module. You can purchase that separately, I believe. Unfortunately, I couldn't get it to work with the app. The app recognizes the device, but there's no option for me to add a RK series power supply. According to the manual, there should be an option. So maybe the app in the App Store has not been updated yet, since this is a relatively new product. Of course, you can also control it via PC using the front panel USB port if you really want to remotely control it. But to be very honest, I don't see myself ever need to do that. Now let's take a look at the output ripple of this power supply. For that, I'm powering the RK6006 using a linear lap power supply, so the ripple from the source can be ignored. The manual does give the procedures for the output ripple testing. This is actually nice, as sometimes the procedures vary slightly between manufacturers, and this could result in inconsistent measurement results if you don't know how it is specified. According to the manual, the output ripple should be tested using ×1 probe. Of course, it also needs to be AC coupled as well. So unfortunately, the Mixtic does not provide a ×1 probe. A lot of the newer scopes these days only provide a fixed attenuation, which is usually ×10 probes. Luckily, I have quite a few older probes lying around, so this one I'm using, you can see here, is switched to ×1 already. The bandwidth limit should also be set, and you can see, let me just double check here, I have already set it. You can see that is 20 MHz, and also the probe is ×1. The manual also called for a 0.1 microfarad capacitor at output, and you can see here I had connected a 0.1 microfarad capacitor at output of the power supply, and also that's the probe input. The power supply currently is set to output 5 volts, so let me turn on the output. And you can see we already started to see a lot of ripples here. So let me turn on the cursor and do some measurements. And as you can see, the ripple is actually not that bad. It is only at 32 millivolts. So this is definitely better than the specified 100 millivolts maximum ripple noise. Now, of course, the measurement is very sensitive to bandwidth. Let's just demonstrate here. So if I, for example, remove that 20 MHz limit, you will see that the noise level is significantly higher. And now let me increase the output voltage and see if that has any impact on the ripple. So let's just change it all the way to 60 volts, 61 volts. And you can see that the ripple noise definitely increased a little bit, but not by much. So now we're at about 40 millivolts. Anyway, from our casual testing, the ripple noise definitely seems to be within spec. And now let's take a look at the powering on characteristics. So for that, I'm putting the scope into single shot mode, and I'm going to turn it on. And you can see that the ramp up speed is actually fairly slow. So let's take a look at the cursor here. From the start to the end, it looks like we are taking about roughly 50 milliseconds for the power supply to ramp up to the desired voltage. And currently the output is set at 5 volts. So let's try that again with 50 volts. All right, right now I have set the output to 50 volts. Let's power it on. And let's measure it. So it's actually taking more than 100 milliseconds for the voltage to reach a stable state. And just for completeness, let's measure the power on characteristics with a load. So right now I have hooked up a 5 ohm and readjusted the output to 5 volts. So let's give it a go. So now let's do measurement again. And it seems we're taking roughly 6 milliseconds. So it definitely seems to me that the control loop on this power supply is on the slower side. But the good news is there is no overshot, as you can see here, during the power on period. And here's another test I want to do. You can see here I set the voltage setting to 50 volts, but I'm limiting the maximum voltage to 5 volts. So as soon as I turn on the power supply, it will detect there's an over voltage situation. So I want to see if there's any voltage overshot in this case. So let's give it a test. And as you can see, the curve looks beautiful. Let me just do some measurements here. So let's first see if we have any overshot here. So the maximum voltage, you can see, is at 5.3 volts, which is very good. It's just about 5 volts. Actually, it might just be 5 volts, as this is not as accurate. Yeah, it's just around 5 volts, which is no issue at all. And let's see the time it took for this power supply to detect this over voltage situation. So let's move it here. All these are just rough measurements. And you can see that it took roughly 0.3 seconds for the power supply to ramp up and ramp down. No issues at all. And just for completeness, let's also test out the overcurrent characteristics of this power supply module. For that, I have hooked up the mixed current probe, and you can see that is on channel 2. So let's give it a go here. And for that, I'm actually setting it both in a over voltage and over current situation. You can see here the output is set at 50 volts, and we have an over voltage protection of 5 volts and over current protection of 3 amps. And also I'm hooking up the same 1 ohm resistor to the output. So this would be a over current and over voltage situation. And let's give it a go and see what we get here. And you can see, let me reduce the channel 2 here. We already know that there's no issue with the voltage, so let's measure the current here. So let me enable the cursor. And you can see we actually cut off at 2.3 amps, and that I suspect is because the voltage limit first kicked in. So let me remove that over voltage protection and do it again. So let me just change it to 62 volts, leave the overcurrent at 3 amps. Let me do it again here. Yep, as you can see now the current is higher, so let's take a look here. And the current is right at 3 amps, so there's no overshot in current either, which is excellent. So from the test we just did, you can see the over voltage and over current protection on this RK6006 are working as desired, and they are working extremely well. For the last test, I wanted to see the maximum power dissipation, and for that I have hooked up a dummy load, and also in series I have a current meter so that we can see how accurate the current measurement is on this RK6006. So right now the output is on, and I'm going to turn on the electronic load, currently set at 1 amp. And you can see we are showing the electronic load drawing about 1.01 amp, and that is actually exactly what is showing on the Unity UT61E. So that means the current reading is also very, very accurate on this RK6006. Now let me increase the current to, let's say, let me do this, 2 amps, 3 amps, 4 amps, 5 amps, and 6 amps. And what you notice here is that, of course, we have some voltage drop because the wires are pretty long. But nevertheless, we showed earlier that at the output, the voltage remains very accurate. Now I have running under this load for about 4 minutes now. You can see that the fan on the electronic load is spinning up. And let's take a look at the thermal situation here. So for that, I'm using my HIC micro thermal camera, and you can see at back here, we have that component reaching 100 degrees. And typically you would want a fan blowing on it, but right now we don't have a fan, so that's actually quite hot. It's 190 degrees by the look of it. By the way, that's Fahrenheit, so it is quite toasty, but nevertheless, the actual fins are not that warm. The fins are about, let's say, it's only 138 degrees, which is perfectly fine. So if you have a fan, probably it will run much cooler, but nevertheless, it shouldn't be an issue as we have already been under load for about 5 minutes now. So supplying above 300 watts is definitely not a problem for this RK6006 module. Anyway, that's pretty much all I wanted to cover in this video. Given how compact the RK6006 is, this module is very versatile and I can definitely see it being used in many applications. Overall, it's a great little DC to DC converter module. I hope you enjoyed the video. If you liked the video, please remember to give it a big thumbs up and remember to subscribe to the channel for more videos like this in the future. I will catch up with you next time.